Welcome back to the course LTE System Overview. Now we will talk about the uplink multiple access technology, which is called SC-FDMA. In the last chapter we were talking about OFDMA, and we talked about OFDMA being the division multiplex technology used in LTE. This is true for the downlink. We also heard in an earlier chapter that OFDM has a high peak to average power ratio, what causes some problems for some amplifiers. Therefore, we have to use very good amplifiers to get rid of this problem. In our cell phones, the user equipment, usually we don't have very good amplifiers, so this means that we have to use a different technology here, which is called single carrier FDMA, single carrier frequency division multiple access. So the subcarriers that are used here are the same as for OFDMA, but we can only use subcarriers next to each other to assign to our cell phone. This means that every user here, the green one, the orange one, and the pink one, has to be scheduled with subcarriers which are neighboring each other. So we cannot distribute subcarriers over the whole frequency range. We can do this in the time domain. So after 1 or 2 milliseconds, we can move the subcarriers that are used for UE1 to a different frequency, but still we cannot arrange them over the whole frequency. This means that if we compare OFDM and SC-FDMA, we have in total a larger bandwidth that is used, and we divide our normal OFDM symbol in some sub-symbols for the single carrier FDM in uplink. Here we see that the same bits can be transported in a slightly different way, but we have no peak power ratio that extends the average power ratio as much as it does in OFDMA. So how is this done? In OFDMA, we were talking about the so-called fast Fourier transformation and inverse fast Fourier transformation. For single carrier FDMA, we are using another mathematical calculation, which is called the discrete Fourier transformation. Then we map our signal on the subcarriers, and then we recalculate to the inverse discrete Fourier transformation. Then, in the end, we can still include or insert our cyclic prefix and send it from the UE to the eNote B. So what we have then is when we have different bits to be transported. So here we see that in a different variant, we will come out with a different output after the discrete Fourier transformation. So a very characteristic wave length profile per user equipment. With another one, the wavelength profile is different. We send this profile to the eNote B, and the eNote B then recalculates with the inverse discrete Fourier transformation and gets out the symbols that were transmitted. This was the multiple access technology for the uplink. So remember, OFDMA is used for downlink, single carrier FDMA is used for uplink. But we still have to talk about another technology, which is the duplex. Duplex means that we have to make sure that downlink and uplink can be transmitted in parallel. What usually is used for the duplex is the so-called FDD, frequency division duplex. This means that uplink data and downlink data, or uplink voice and downlink voice, are just sent in 2 different frequency ranges. For example, in GSM, we have a time slot for downlink in a certain frequency range, and the same time slot is mirrored in another frequency range for the uplink. However, in UMTS and LTE, we can also have a so-called TDD, time division duplex, where we send uplink and downlink after each other, and therefore we can make sure that downlink and uplink seem to be parallel at the end user, but in reality they are sent one after each other. Because we can configure the length of the uplink and downlink periods, this is a duplex method that can be used when the traffic between uplink and downlink is very different. So when we have more uplink than downlink, then we will extend the uplink period. If we have more downlink than uplink, we will extend the downlink period. However, usually FDD is used. So far for multiplex technologies and duplex technologies. Thank you for watching.